Hi everyone, and welcome back to the video series where we are learning how to operate with fractions conceptually and using the CRA approach. So today I'm going to be doing division of fractions, and I'm going to be doing division of unit fractions. Now when we're doing multiplication or division of fractions, it kind of stumps the students because what they're used to seeing is when we multiply two whole numbers together, if they've only worked with whole numbers so far in operations, when we multiply two whole numbers together, we end up with a larger number, and when we divide two whole numbers, we end up with a smaller result. But in fractions, especially unit fractions, oftentimes it's the opposite, and this can confuse a lot of students. So I'm going to show you why that happens today, and I'm going to move you through the CRA approach as always, and I'm going to start with the folding of paper. I'm using circle paper here because I think that just for division it works a little bit better. So these I got from Officeworks. You can get a pack of about 500, and I think they're around, I don't know, $5, $6, I can't remember, but you get them from Officeworks if you want. So I'm going to start with two basic unit fractions. I'm going to say 1/2 divided by 1/6, and I'm going to show this using my folding paper first. Now, as always, I like to start with the language that we use when we're working with operations. Now, in multiplication, remember, we were talking about groups of, but in division, I want to talk about what this means when we're working with division. So I'll get the students to look at that and change the way that they say that, or the way that they think about that division sign. So when we learn division, first of all, with whole numbers, we look at sharing or how many. So I'm going to get the students to change the way they think about this or the way they say this, and I'm going to say 1/2 how many 1/6, or how many groups of 1/6 will be in 1/2, and the result of this will make a lot more sense when we think about it in this way. So let's make a start. So first off, as always, I want to start with my first fraction, and that is 1/2. So I want to say, if I had 1/2, how many 1/6 will fit into my 1/2? So the first thing I want to do, and you might see why using circular paper works so well in this particular problem. So here's my 1/2. I want to know how many 1/6 will make up my 1/2. So I get my second piece of paper and I fold this into 6. So I fold it into half, and again, thirds is not always very simple, but for circles it is slightly easier than for a square bit of paper, and you basically fold it into thirds as such. Okay, so if I open this up, I can see that this little wedge here, segment, will be our 1/6. So that each one of those little segments there is 1/6. So I want to know how many of these make up this. So what I'll do is I basically look at this and go, okay, well, I've got 1/6 there, and if you really want to, you can place a line. Then I've got my second 1/6, and then I've got my third 1/6 over here. So if the question is 1/2 how many groups of 1/6, I can see that there are 3 1/6 that fit into 3 1/6 will fit, or let's say make up, make 1/2. So that will be your quotient, okay, that little 3. And I'll show you over here how to do that using the process. And doing it this way will make the process make a lot more sense. Like, why is it then that when we divide two fractions, we actually get a whole number? Generally, it doesn't make sense. But what is actually happening is we are asking ourselves how many. And it is not 3, it is 3/1/6 when you put it in context. Now, as always, you can get the students to draw this out in this way. 1, 2, 3, 1/6. Or I also like to get them to represent it as a number line, because as a number line, you can see it in a different way. So here I want to know how many of these 1/6 will make up 1/2. So here's my 1/2. And if I go back and say how many 1/6, so if I then break up my whole or partition my whole into my sixths, each one of these being 1/6, I can see that it is 1, 2, 3, 1/6. So this is 1/6, 1/6, 1/6. Not a great whiteboard marker, but you get the idea there. So this is why the answer is 3. Now, how about the abstract method? Because often when we teach division of fractions, we teach it using the stay, change, flip, or the keep, change, flip. So stay, change, flip, which means we keep the first fraction as is, we change the division to a multiplication, and we flip the second fraction or the divisor. Now, it adds a lot of confusion. Students don't know why they use this method, but what they're doing is they're finding what we call the reciprocal. So when I flip over or change over the numerators and the denominators, when I flip that fraction over, what I'm actually finding is my reciprocal of that particular fraction. And what that means is when I have a fraction like 1/6, I'm actually saying how many 1/6 make up my whole, okay? And that's why you change. So you're changing this to its reciprocal form. So I'm saying 1, 2, 3, 4, 5, 6 make up my 1 whole. And it'll always work when you're working with reciprocals. Now, the reason why we're changing this sign to a multiplication is because I actually am changing the form that I'm seeing this as. And what I'm saying is, if I am trying to say how many 1/6 will fit into my 1/2 or make up my 1/2, what I'm actually saying is 1/2 of my 6 pieces of my whole. 1/2 of that 6. So if I open this back up again this way, so when I say 1/2, how many 1/6, 1, 2, 3, I can also change that language and say, well, actually, what I'm saying, because multiplication and division are inverse operations, what I'm actually saying is if I had my whole, what is half of that whole if I have divided my whole into 6 parts? And it is 1, 2, 3. So the quotient will be 3, because obviously when we do a multiplication, it is 1/2 times 6/1. We multiply our numerators and our denominators together. 1 times 6 is 6, 2 times 1 is 2, 6 divided by 2 is 3. So that is 3, 1/6 make 1/2, or half of 6, 6. What is that? How many parts? That is 3 parts. So there you go. Simple conceptual way of teaching division. Now this, I just want you to keep in mind that when you're doing these sorts of things, we want the students to eventually use this approach. Okay, we don't want them to continue to shuffle and around and fold bits of paper, although if it is useful to them, that's great, they can do that. But we want to use this approach to explain this method. Why is it that when we use this approach, we get certain results? And why is it that we use this process? So that is fundamentally why we use the CRA approach. We want to get to the abstract, but we want to understand the steps leading up to that abstract process. So that's it. I hope you enjoyed that and got something out of it. The next one, I will go a little step further and hopefully I'll see you then. Bye.